Hello! This lesson is entitled 1D Motion Problems 4. A boy runs from inside a garage and slides down an icy driveway. At the top, he moves at 2.3 meters per second. He slides down in 4.5 seconds, accelerating at 0.75 meters per second squared. How fast is he moving at the bottom? So, let's use the guess method. What are we given? We're given his initial speed, 2.3 meters per second. We're given the time, 4.5 seconds. And we're given his rate of acceleration, 0.75 meters per second squared. And we're asked, how fast is he moving at the bottom? Which is the final speed. So the equation that's going to govern this problem is the definition of acceleration. Let's see what we're given. There's the initial velocity, there's the time, there's the acceleration, and we're asked to find the final velocity. So I think we're not going to worry about that portion of the equation, and let's now solve this equation for the unknown. So it looks like to do that, we first need to multiply both sides by delta t, and then add vi to both sides, resulting in this expression on the right. And only in the final step do we put the numbers in and crunch them. 0.75 meters per second squared times 4.5 seconds plus the initial speed of 2.3 meters per second, 5.7 meters per second. How long is the driveway? Here are the quantities that we are given in our problem. And how long, in this case, is asking what's the displacement, or since it's a straight line, it turns out to be equal to the distance, and it doesn't really make a difference whether we refer to displacement or distance because they have the same magnitude in this case. I'm not going to derive this expression for you. I'm just going to go ahead and give that to you. Displacement is equal to initial velocity times time plus 1/2 times the acceleration times the time squared. I'm going to get rid of those vertical arrows because we're dealing more or less with horizontal motion. Driveways tend to be horizontally oriented. And it looks like we know everything on the right side of this equation. We know the initial velocity, we know the time, we know the acceleration, and there's the time squared. So go ahead and type that into your calculator. Make sure it comes out to be 18 meters. How about this one? Assuming the same acceleration, find the time for him to reach the bottom if he starts at the top from rest. In the earlier example, he started at the back of the garage and got a running start, so that when he hit the driveway, he was already moving. But let's say that he didn't do that, that he just started from rest at the top of the driveway. Then how long would it take him to reach the bottom? Well, if we start with this relation here, the initial velocity this time is 0. So that means that this portion of the equation can essentially be crossed off. We know the acceleration, we're looking for the time, and we know how long the driveway is, 18 meters, because we figured that out in the previous example. So if we solve that expression for time by multiplying both sides by 2, dividing both sides by a, and then taking the square root, make sure you are able to get from this expression down to this one. And now we're just going to put the numbers in. 2 times 18 meters divided by our acceleration, 6.9 seconds. We would expect a time greater than this one in the upper right of 4.5 seconds. It took him 4.5 seconds to get to the bottom when he got a running start. So when he doesn't get a running start down here in the lower right, we would expect the time to be larger. Final thoughts on 1D motion problems 4. 1. Here we went through a multi-part problem in 1D kinematics. We started out using the formal guess method, and then showed how one can approach problems in a slightly less formal way. 2. We also met the third equation that we'll need in kinematics. We need only one more to complete our equation toolbox that will get us through the rest of 1D and 2D kinematics, and we'll meet that one next time. Thanks for joining me.